Okay, guys, so in this moment I show you in the board different shapes that you maybe know about the different geometrical forms that exist in physics or in geometry. Ready? So the first is the cube. The second is the rectangular prisma. The third is the sphere. Excuse me. Sphere. The fourth is the cylinder. And this is the pyramid. If you see, these shapes has different geometrical shapes. In this case, is the mixture of some different squares. These are rectangles in 3 dimensions. This is a spheres. This is a cylinder that has a circle and a rectangle, and the pyramid that is a triangle in three dimensions. Ready? So in physics, I'm going to show the different equations that represent the calculus of volume, because it's an equation that show me how can I calculate the corresponding information of one figure. Ready? So the volume of cube is side per side per side, but in Spanish I'm going to put lado por lado por lado. But if you want to put in English, side by side by side. Ready? Side. In your glossary is lado. Rectangular prisma, that is a rectangle in 3 dimensions. So I can calculate the volume of the rectangular prisma showing base per height. Teacher, what is the meaning of base or what is height? It's the same to say light per side by side by side. That is so it's totally similar to the cube. That is lado por lado por lado. Okay, this is the volume of the rectangular prism. I have the other geometrical shape, that is the cylinder. How can I show or how can I represent the volume of a cylinder? Is P per r square per height. Oh, teacher, I don't know what is P and what is this strange symbol that I don't see in one moment of my life. Ready? So height, h is the height. Ready? P, that you have to find in your calculator. Ready? And put in your calculator that has a value of 15. Ready? And earth, that in this case is the radio. The radio, remember, that is the distance between the center of the circle to the extreme, up to the other point. Ready? This is the volume of the cylinder. P per r square per h. In a moment, I'm going to show you how you're going to calculate this. And the pyramid, I have that the volume, in this case, is by side or base per height per area, and over 3. Over 3. Ready? In this case, I don't going to show you how to calculate the pyramid, because show different things and you need maybe some geometrical contribution of the calculus of the integers. Ready? So I'm going to continue with these geometrical shapes. Ready? And finally, we have the sphere. The sphere that has a volume of 1.3 per p per radio to the cube. Ready? Entonces, radio a la 3. Okay. 1.3 per p, that is the same value, 3.1415 per radio to the cube potence. Ready? So basically, this is the equations that show me how I'm going to calculate the volume in regular shapes. So I'm going to show you one example, making some different ideas or some different contributions about the dates of common situation that show the geometrical figures. So in this case, I can calculate the volume of this glass, ready, of this object, because of course has shape of cylinder, ready, and I can measure with a ruler the distance between the center of the top of the cover of the other extreme, that is the radio, and the height of the glass of the bottle, ready. So I'm going to show you an example finally to discover the volume of a figure, ready. And so I'm going to plant the exercise ones. I'm going to calculate the volume of this basketball ball, ready. The basketball ball approximately has a radius of 10 centimeters. Ready? So, I'm going to calculate the volume of the sphere. First, I have to find, of course, or I have to define the regular shape that has this object. So, of course, it's a sphere. So, I need the equation that show me the volume of the sphere. That is 1.3 per P per radio to the cube potence. So I have the radio. Remember that the radio is the half of the diameter. Ready? Diameter, diámetro, radio, radio is the same. Ready? Diámetro y el radio es la mitad del diámetro. Okay, so the volume of the sphere, was the figure that I select. This is the general equation. So in this moment, so I'm going to use the calculator to represent the volume of this figure. That is 1.3 per 3.1415 per the radio, that in this case is 3 per Hertz potence. And you can say, teacher, how can I represent this in my calculators? So I'm going to give you a short tip in the following part of the video about how to put this in your calculator with some images that I'm going to take. Ready? So don't forget, with this I'm going to help you with the configuration of your calculator to show you this part. Ready? This is the exercise number 1, and of course I can determine the ideas. I can determine, the information, that the result that I show you in the problem. Ready?